When building apps, it is important to make them structured and informative so that they are easy to use and understand. There are several application builder tools and features that we will demonstrate in this video. We will go over the main window node and create a file menu and ribbon for our app. We will discuss the difference between sketch and grid modes, and we will go over the different types of subforms. That is, you will want to create multiple forms when adding more features to maintain an organized app. These tools will help you transform a simple, unassuming app into an informative and well-designed simulation tool. The app we will be using to demonstrate these features was built in a previous video and uses the busbar model as an example. If you are already familiar with the form wizard, editor tools, and how to build a simulation app in general, then this video will help you to organize the app. Now, this app is fairly simple. We have one form and one method. However, as you continue to add more features to your app, you will need to keep your app organized. A good place to start is with the main window. In the settings window, let's focus on the menu type, and we can choose between the menu bar, which is the default option and provides a file menu, or we can choose ribbon, which is the same as what you see here in COMSOL Multiphysics. Let's go with a ribbon menu type, and under the main window node, we have a ribbon node, but we also are able to add a file menu to the ribbon, so we can have both in our simulation app. Let's start to include some menu options that will be useful to the user, such as being able to save the simulation app in its current state. To do this, we can click the item button, and we can update the text to reflect the functionality. So we enter save. Then under icon, we can scroll down and choose an icon already available through our COMSOL installation. Now under choose commands to run, under GUI commands and file commands, we can choose save application and click run. Let's also include an item for the user to save as. So let's click the item button again, update the text to save as, and then scrolling down, we once again have another icon available for us to use. And under GUI commands, file commands, we can click Save Application As, and then click Run. Currently in our app, you'll notice that the buttons are located within the form. However, for most of the apps in the application library, you'll notice the buttons are actually included in the ribbon. So let's make changes to incorporate the functionality these buttons serve into the ribbon of our simulation app. So first, we will need to create a tab for the ribbon. So we can click the ribbon tab button, and we can rename this to dashboard. And in our ribbon tab, let's include two ribbon sections to group and organize the buttons into separate areas. So we click the ribbon section button, and the first section, let's title simulation. And let's add another ribbon section and rename that documentation. Under the simulation section, let's include the functionality to update the geometry and compute the model. So first we select simulation, and then we can add an item. Let's change the text to update geometry. We can also change the icon to the geometry icon. And then under choose commands to run, we can go into the model component, select the geometry node, and click plot. And we'll want to make sure that the geometry is plotted in the graphics window in our form. So we can select that box and edit argument. And under form 1, we have the graphics window. And if we click the update geometry button, we can see we've implemented the same functionality. Now for the compute button, we can see the command is to run method 1, which we defined earlier. So now, once again, under the simulation section of the ribbon, let's add an item, change the text to compute, and add the respective icon. And then under methods, we can select method 1 and then click run. Lastly, under the documentation section, we'll want to add an item to create the report. And we can see the command here is to run report 1. So let's add another item, change the text to create report, change the icon to the results report 32 icon, and then once again going under the model component and expanding the results node and reports node, we can select report 1 and then click run. So in many application library apps, there's usually a button that opens a PDF document containing helpful guidance or instructions on how to use the app. So let's also include this in our simulation app. First, let's add a separator, and then we will add another item. Let's title this item App Manual. And for the icon, we can use the PDF icon. And now we need to specify the command to run. First, we need to add the PDF containing the model or app instructions to our library. So if we go to the left and expand libraries and go under files, and we click add file to library, you just need to navigate to the appropriate folder under which you can then select and add the PDF to your library. And from there, we can return back to the app manual item. And under GUI commands, we can expand that, as well as the file commands branch, select open file, run, and then for the arguments, we can edit the argument. And if we scroll down, we'll notice the PDF file that we just added is available to be selected. So now when a user clicks the App Manual button in the ribbon, it will open the simulation app PDF file. At this point, all of these buttons in our form are duplicates of the functionality included in our ribbon, so we can go ahead and delete all of these. Now, if we want to quickly test the application, you can see all the functionality is housed up here in the Dashboard ribbon tab, and we can update the geometry, compute the model, generate a report, or open the simulation app instructions. So if we click this, we have a help document PDF file that opens up. Note if I try to adjust the size for our simulation app, it is not responsive. And we can actually use some features to make our app responsive. These features that structure our app are determined by the layout we choose. And we have two options for this: sketch mode or grid mode. So sketch mode is great for just quickly dragging and dropping different form objects around where you want them in the model. We can use grid lines to make sure things are lined up. And we can also always choose to select and then align certain form objects where we would like them to be positioned. But realistically, if you want to create a more structured app and have it be responsive, we need to utilize grid mode. To make our app responsive, we'll want to remove some of these extra columns in our grid, and we'll want to set this column as a grow column, and then this row as a grow row. And we'll want this graphics window to fill this grid cell horizontally as well as vertically. Now, if we test the application and resize the window, you can see the graphics window in the app resizes appropriately. At this point, the body of our app is structured and resizable, but the different items are hard to differentiate. Let's fix this by improving the design of the user interface. When it comes to maintaining a certain degree of organization when adding more and more form objects and features, subforms play an important role. Under the Insert Objects button and under the Subforms grouping, we have forms, form collections, and card stacks, as well as information card stacks that are included in the composite grouping. But instead of creating a new form from scratch, we can use the Control or Shift key and select multiple objects, and then click Extract Subform, and this will create a second form in our app. If we return to the Form 1 node, you'll notice now that a form object has been created. And once we start creating additional forms, it's helpful to rename them so that it is clear what parts of the app you're working in. Let's rename Form 1 to Main, since it is the main form. And likewise for the name, also enter main, but with a lowercase m. Note that doing this will break the connection to some of our arguments in our commands to run. For example, if we return to the Update Geometry item, you'll see here that the command is set to plot the geometry under Form 1. Since we've changed the name, we need to edit the argument and update this to be under the main form in the Graphics 1 window. We will also want to rename Method 1 just to be more descriptive, so we can change the name from Method 1 to Compute Method. And you'll see trying to enter that as the name comes up with an error, and this is because we've included a space in the name, which we cannot do. So we simply can replace that with an underscore. When developing an app, a best practice is to rename forms or subforms as early as possible. This prevents having to update arguments in the command sequence and having to update any form objects whose connections broke. Let's also rename Form 2, changing the title to Report Output Format, and then changing the name to Report, and this time using an underscore format. Alright, we have this form, Report Output Format, and we need to incorporate this back into our simulation app. It currently exists in the Simulation App's user interface, but this isn't necessarily the best place for it, since it is only needed when a user wants to create a report. To control this and make this appear only when a user clicks the Create Report button, we can create a dialog box. To start this process, let's return to the Report Format form, and let's switch to Sketch mode. And keep in mind that you're not restricted to using either grid or sketch mode. You can use both in your simulation app. And first we'll want to add a button for our dialog box. So under Insert Object, let's click Button, and we'll change the text to that to OK. And for the commands to run, we can go under the model component, under Results, and under Reports, select Report 1, and then click Run. And we'll also want for the dialog box to close. So let's go ahead and move this button up here. And let's now insert another button, this time changing the text to Cancel. And all we'll want to happen is for the dialog box to close. So this gives our users an out if they accidentally clicked the Generate Report button. Now, before we go ahead and finish this up, there is one more setting we need to specify. In the Settings window for this form, our dialog box, in the Dialog Settings section, we'll want to change the setting for Store Changes to immediately. Now, the output format selected will immediately be stored in the app as we make the change. This is important because if we do not store the changes immediately, the output format that we change will not be taken into effect until after the report is generated, which renders this functionality obsolete. So this is just an important setting to take note of when you are creating a dialog box. Now let's return back to the main form, and we can go ahead and remove this form. And under our create report item, we're going to remove this command to run the report. And instead, under the forms branch, we can select report format and then show as dialog. And let's test the application to see this functionality. All right, so if we click create report, the dialog box appears, under which we can choose the output format. If we click cancel, the dialog box closes. And if we click Microsoft Word and click OK, a report has automatically been generated. So let's continue organizing and structuring the remaining form objects in our app. You can see here we still have several inputs as well as an output. We can organize these form objects and their display by extracting them into separate subforms and then using a form collection. To start, let's go ahead and create a subform for the inputs by selecting all of the cells with respect to the inputs in our grid, and then clicking Extract Subform. Similar to renaming a form, when organizing and restructuring your app, certain form objects might break. We can always update them by selecting the form object, going into the settings window, and then reconnecting the form object to its source. Now we can change the title of the form to Inputs and change the name as well. Let's return to the main form, and we can also do this with the outputs. Select the output cells in our grid, extract the subform, and we can change the title to Outputs, as well as the name. At this point, we can go in the main and remove these forms. Get rid of the extra columns, as well as the extra rows. And here in this cell, we can insert an object and choose Form Collection. In the Settings window, under the Panes section, we can choose the Inputs and Outputs as panes, and then change the type of display that we want to sections. Note that the titles for each section are pulled from the title that we entered for each subform. And to make our app more clear, let's go ahead and add some additional form objects. First, let's insert another row. And here I will insert a text label. And we'll change the text to simulation data. And let's do the same. Add another text label and change the text to graphics. I want to change the appearance of the text, so a little trick I can utilize here is I can select both text boxes, and then I can change the color to a custom color and choose this blue. I can change the font to Vera, and let's choose a font size of 12. And you can see those changes were made to both of the form objects selected all at once. Let's also make some changes to include some separation between the text and the rest of the user interface. Let's add a column between the simulation data and graphics. Let's go ahead and merge the cells. And let us enter a line form object. But right now we can't see it because the orientation is set to horizontal. So let's change it to vertical, and you can see that. And let's also do this horizontally across the app by inserting a row below, and then in this grid cell here, inserting a line, and then doing the same under the graphics text. If we test our application now, we can see our simulation app's user interface is much more clean and descriptive to the user, as well as smoother to navigate. Finally, let's take a look at card stacks. As mentioned before, there are two kinds of card stacks available: regular card stacks, which are flexible and customizable, and information card stacks, which are simpler to make. So let's start here. To demonstrate this functionality, let's say we want to notify the user as to whether or not the simulation was successful, under the conditions which we have set in our method. That is, a simulation is successful if the maximum temperature falls below 500 Kelvin, and a failure if the temperature exceeds that. So before adding a card stack, we will need to add a checkmark image to our libraries to show the simulation as a success. To do this, we can go to the Images node, and we can click Add File to Library, and you'll see we have a plethora of icons and images available from our COMSOL installation to utilize. I'm going to use check_32 and open that to add it to the library. And now we can return to our main form. And let's add another row below the inputs and outputs. And here in this grid cell, we can insert an information card stack, under which we'll want to add an information card. Here we have some pre-built information cards for the solution status, which is something you'll find in most of the application library apps. However, we want to define a custom card, so we click that option. And the icon we want to use is the one we just added, check_32. And for the text, let's enter the temperature falls within the 500K threshold. And click OK. And we will want to add another custom card, this time indicating when the simulation fails. So we can use error, and then change the text to say, the temperature has exceeded the 500K threshold. And we can click OK. And those information cards have been added. At this point, we need to differentiate between the cards and when they are displayed. So at this point, we want to bring in declarations. Declarations can be used as sources for form objects if you want a setting in your app that doesn't have a one-to-one mapping to a setting in the model tree. For example, in this section where we select our source, we can only choose from parameters or the report output format. So we need to create a source to tell the information card stack whether the simulation has passed or not. This is where declarations come in. Since this is a yes/no answer, we can go under scalar and add a boolean. By default, the boolean's name is bvar, but we can change the variable name to be more descriptive and call it btemp, keeping b for boolean. And we can set the initial value to true. Now if I return to the information card stack, you can see under declarations, we are able to add that btemp variable and use it as our source. Now we want to enter the text for when each information card is displayed. So we'll change the text custom 1 to true and custom 2 to false. And now we'll want to implement this in our compute method. So here in our if-else statement, we can go to the end of the if portion and enter a line. And if we open the editor tools window, we can go under declarations, under Boolean, select btemp, and then click set, and leave the default value of true there. Then under the else part of the statement, we can once again click set, but this time change it to false. So now when the maximum temperature falls below 500 Kelvin, the success information card displays, and when it falls outside of that threshold, the false information card displays. Let's test the application now. If we change the applied voltage to 80 millivolts and compute, we can see the card display changed to the error message. And if we reduce the applied voltage to a lower value and compute it, here we've entered 40. You'll see the success information card has displayed. So now, knowing the simulation is a success, the user can now generate a report and select between the two format options. Now that we've shown how information card stacks work, let's quickly look at how a regular card stack would look. So let's add another row under our information card stack. And here, under Insert Object, we can add a regular card stack. So this works similarly to an information card stack, except when you click to add a card, this adds a completely new form. So if we click OK, and then want to edit it, you'll see it brings us to a new form tab. And this form only exists within the card stack. You can see here in the tab the breadcrumb that this card exists in the card stack, which is contained in the main form. So in regular card stacks, you can include as many form objects as you want, whereas with information card stacks, you are limited to displaying an image with text. Now you know how to create an organized and informative app that will be easy for your app users to understand and immediately benefit from. For more information on specific features, check out the comprehensive Application Builder Manual in the PDF Documents section of the COMSOL Multiphysics installation.